Greetings everyone. Myself Muskan. I'm a student of BSc Chemistry Honors second year. Today I am here to explain the topic of organic chemistry, that is non-aqueous solvent. We will start our chapter. Most of the chemical reaction are carried out in a solution, and the behavior of the substance also depends upon the nature of the solvent. In earlier days of development, the industry reaction have been carried out only in one solvent, namely water. It has been facilitated by its ready availability, ease of purification, together with its favorable physical and chemical properties such as long liquid range 0 to 100 degree Celsius, high electric constant, that is 78.5, specific heat of volatilization, dipole moment, etc. Water is neutral, odorless, and non-toxic and non-poisonous. It can therefore be handled safely. The property of water make it excellent and useful solvent for large variety of substance. In fact, the excellent property of water have hindered the development of non-aqueous solvent. The solvent other than water which is used for carrying out the chemical reaction are called as non-aqueous solvent. Attempts have been made to find some other solvent which could behave as a better solvent or good solvent like water. Organic chemists have been using many solvents such as benzene, carbon tetrachloride, acetone, ether for dissolving organic compounds which are insoluble in water. There are many other solvent availability, for example liquid ammonia, H2SO4, that is sulfuric acid, liquid HF, liquid sulfur dioxide, etc., which have been frequently used. In the present unit we shall discuss this solvent, non-aqueous solvent, physical property of a solvent and their role in chemical reaction. The usefulness of a solvent is determined from its specific property that may help to carry out the chemical reaction and separate the product more conveniently. Some of the important physical property of the solvent are discussed below, such as first one is melting and boiling point. The melting and boiling point of the solvent determine the temperature range within which the solvent which can exist in the liquid state under atmospheric pressure. Since most of the reaction in a solvent system are carried out in liquid phase, the melting point and boiling point give the temperature range within which the solvent is useful. The melting point and the boiling point for some common solvent are given below. From this table, it is clear that water has excellent liquid range 0 to 100 degrees Celsius at ordinary temperature and pressure. Acetic acid can also act as a solvent at ordinary temperature, while ammonia and SO2 can act as a solvent only at low temperature. Now we will discuss heat of fusion and heat of vaporization. The value of heat of fusion and heat of vaporization help to know the nature and strength of the force which holds the molecules of the solvent together in a solid or liquid state. As we know, the amount of heat observed by 1 mole of substance to change from solid to liquid is called molar heat of fusion. Similarly, the heat absorbed by 1 mole of substance to change from liquid to vapor state is called molar heat of vaporization. Large the value of heat of fusion and or heat of vaporization, stronger are the intermolecular binding forces in the liquid or the solid respectively. Therefore, the magnitude of molar heat of fusion and molar heat of vaporization give us some insight in the nature of strength of the intermolecular force that are determined also solvent properties. A better idea of the intermolecular force in a solvent is obtained by the ratio of molar heat of vaporization to the boiling point. The ratio is known as Thornton constant. For normal liquid, the molar heat of vaporization are expressed in calorie and the boiling point of absolute scale. Then the Thornton constant has the value of 21.5. A higher value of Thornton constant indicate associate molecule. For example, a common solvent like water, ammonia, hydrogen fluoride have Thornton constant value greater than 21.5 and therefore associate liquid. The molecule of these liquid are polar, and the association of polar molecule is due to the tendency to orient themselves so that they oppositely charged and of the molecule come near to each other. Now we will discuss our third point, that is dielectric constant. This property is a measure of a polar nature of a solvent and help to estimate the solubility of polar or non-polar substance in a solvent. According to Coulombic law, the force of attraction between the two charged particles is given by this formula. We can see here Q positive and Q negative are the charges of cation and anion respectively. Where are the distance between them? E is the constant called as the dielectric constant of a solvent. If epsilon is large, the force will be small. As a result, only a small amount of energy will be required to separate the ions. Hence, it will be easy to dissolve an anionic substance. Thus, in solvent of high dielectric constant, the ionic substance will dissolve readily with the decrease in dielectric constant, and the solubility of the ionic compound will decrease. Now we will discuss dipole moment. The dipole moment is related to a dielectric constant of a solvent. An ionizing solvent has large dipole moment and also have a large dielectric constant. It is related to the polarity of the bond in the molecule. The greater the polarity of the bond in the molecule, larger is its dipole moment. Solvents have a high dipole moment, having greater tendency to dissolve the polar and ionic substance. This is because of the fact that the greater polarity result in strong bond between the solvent and the solute molecule, and large solution energy is released. Thus, large solution energy is sufficient to overcome the lattice energy in the solute molecule and help in dissolving the solute. Viscosity. Now we will discuss viscosity. It is a measure of fluidity of a solvent like water, ethyl alcohol and carbon tetrachloride have low viscosity and high fluid and flow rapidly under ordinary temperature. On other hand, anhydrous sulfuric acid and high molecular weight hydrocarbon have high viscosity and flow at much lower rate at ordinary conditions. In solvent of low viscosity, the operations such as precipitation, crystallization, filtration, etc. can be easily carried out without any difficulty. With the increasing the viscosity of a liquid, increase the difficulty of such operation. Now we will discuss the type of solvent. Non-aqueous solvent has been classified in many ways. The following are the important classification based upon the chemical property of the solvent. First one is protonic and non-protonic solvent, acidic, basic and amphoteric solvent. Third one is ionizing and non-ionizing solvent. Fourth one is coordinating and non-coordinating solvent. Now we will discuss protonic and non-protonic solvent. The solvent which have from which we can gain H positive ion are known as protonic solvent. Therefore, protonic solvent contain ionizable H positive common ion. Common example of this protonic solvent are H2O, HF, H2SO4, HCN. The solvent from which the proton cannot be ordinarily derived are called as non-protonic solvent. These are also called aprotic solvent. In other words, these solvents do not contain ionizable hydrogen atom such as SO2, N2O4, C6H6. Now we will discuss acidic, basic and amphoteric solvent. The classification is based upon the acidic or basic behavior of the solvent. The solvent which have a strong tendency to donate proton are acidic in nature and are called acidic solvent, or protogenic solvent which have high tendency to accept the proton and are in basic nature. They are known as basic or protophilic solvent. The solvent which have neither have a strong tendency to gain nor a strong tendency to lose the proton are called as amphoteric or amphiprotic solvent. Now we will discuss ionizing or non-ionizing solvent. The solvent which are capable of undergoing self-ionization or auto-ionization are called as ionizing solvents. Some common examples are H2O, HFSO2. These solvents are generally polar or ionic in nature. On the other hand, the solvents which do not ionize at all are non-ionizing solvent. Fourth one is coordinate or non-coordinate solvent. The solvent which are capable to coordinate with the metal ion or anion of the solute are called coordinating solvent. On other hand, the solvent which are not capable to coordinate with the metal ion or metal ion or anions of the solute are called non-coordinate solvent. Now we will discuss type of reaction in non-aqueous solution. There are following types of reaction commonly occur in non-aqueous solvent. First is meta metathetical or precipitation reaction. Second is salt formation. Third is acid base reaction. Fourth is solvatic reaction and or solvalysis. Fifth one is solvation. We will discuss it in further lecture. Now we will discuss liquid ammonia. Liquid ammonia is one of the most extensively studied non-aqueous solvent. It is now used as a highly useful solvent and the reaction medium for many type of organic and inorganic synthesis. Its most of the physical properties resemble those are in given below. Comparison property of liquid ammonia and water. The comparison property of liquid ammonia and water reveals the following point. First one is liquid range. The melting and boiling point of liquid ammonia are lower than those of water. In liquid ammonia, the liquid range is -77 to -33 degrees Celsius, and therefore it present some of the water in liquid. Therefore, some precautions have to be taken while using the liquid ammonia as a handling problem. Therefore, some precautions have been taken. It is generally handled in cool vessel, and nowadays a wide range of technique have been advanced for handling it. Second one is hydrogen bonding. Like water, liquid ammonia is an associate solvent through the hydrogen bonding because it contains a strongly electronegative element, that is nitrogen. However, ammonia molecules are less strongly associated because nitrogen is less electronegative than oxygen. Therefore, NH bond is weaker than OH bond. As a result, the freezing point and the boiling point of ammonia are less. Since ammonia is a less associated than water, it is a better solvent for organic compound. Now we will discuss its dielectric constant. The dielectric constant of a water is 22 at -33.5 degrees Celsius is lowered as compared to the water, that is 78.5 at 25 degrees Celsius, suggesting its lesser tendency to dissolve ionic compound. Now we will discuss self-ionization. Both liquid and ammonia show comparable self-ionization are represented as we will see the reaction. Ammonia is a better solvent than water. Liquid ammonia is a poor conductor of electricity. The specific heat of ammonia is more than water because of a high melting point. Liquid ammonia is less viscous than water, most stable Most salt, when dissolved in liquid ammonia, conduct electric current better than in water. This is due to the ionization power of ammonia, but due to the low viscosity, which greatly increase the mobility of ion. Liquid ion has high critical temperature and pressure. It is less associated than water and therefore it is a better solvent for organic compound. Liquid ammonia form a strong reducing and metal ammonia solution with alkali metal. Therefore it is a excellent solvent for many reduction reaction. Now we will discuss reaction of liquid ammonia. As mentioned earlier, ammonia has water-like property as a solvent, and it is therefore expected that reaction which take place in aqueous solution can occur in ammonia solution. So there are many reaction with the ammonia. Let's have a sight on this reaction. First one is acid-base reaction. When acid and base reaction of in liquid ammonia can be easily understood by the comparing of a reaction in water. There are, second was is acid base neutralization reaction. It also reacts with amino acids. It also react with the amino base. Second one, it is show precipitation reaction. Precipitation reaction involves double in decomposition because of the difference in the solubility of various substance in water and in liquid ammonia. Third one, it show ammonolysis. Now we will discuss the disadvantages of liquid ammonia as a solvent. The liquid range for liquid ammonia is from minus 33.3 to 77.7 degrees Celsius. Therefore, a low temperature and pressure is necessary while working in liquid ammonia. Liquid ammonia has an offensive odor, therefore, it requires special technique to use it as a solvent and a reaction medium. Liquid ammonia is hygroscopic in nature, hence, all the reaction are to be carried out in sealed tube. Now we will discuss liquid sulfur dioxide. Liquid sulfur dioxide is a non-protic solvent and a aprotic solvent because it does not contain any hydrogen atom. It is also one of the important non-aqueous solvent and widely used in industry. Under normal condition, the temperature and pressure, the sulfur oxide is a gas, but it can be readily liquefied and easily maintained in a liquid phase. It has a wide liquid range, that is minus 10 degrees Celsius to minus 75.5 degrees Celsius. Can be used as a solvent. It can be easily purified by passing the sulfuric acid in the form of gas through P2O5 to remove the traces of water. Its dielectric constant is small, that is 15.6 at 0 degrees Celsius. Therefore, it is a good solvent for covalent compound. The characteristic and physical properties of the liquid sulfur dioxide are given below. The valence bond theory predicts that the SO2 molecule is a resonance hybrid of the following two resonating structure. Now we will discuss the reaction of the sulfur dioxide. Some important chemical reaction in sulfur dioxide discussed below. First one is acid base reaction. Liquid SO2 undergo autoionization according to the solvent system concept of acid base, and the compound which gave thionyl ion in a solution of SO2 would behave as a acid, whereas compound giving sulfite ion, that is SO32 negative in liquid SO2, would act as a base. On other hand, We can also say it show auto amphoteric behavior is with the zinc and aluminium. It shows solvatic reaction. It also show precipitation reaction. Now we will discuss its Now we will discuss some special feature of liquid SO2 as a solvent. Liquid sulfur possesses some special advantage over other solvent as a reaction medium. First one, it has a low melting point and this allow its easy evaporation and therefore removal from the reaction mixture. It has a low melting point and therefore it allow reaction to be carried out at low temperature. Liquid SO2 is an inert solvent. It has unusual solvating power for both covalent and electrovalent compound. It is a better medium for covalent compound like hydrocarbons and is used for the purification of some petroleum product. It is also used as a deliquent for super acidic medium which help it in reducing the viscosity after affecting the acidity. Thank you. Have a nice day.